Welcome to our channel Sankalp Study Success. Today in this video we are going to learn about minimization of finite state machine. That is, we have already learned what is a finite state machine, and we have two types of finite state machines which are nothing but DFA as well as NFA. Now we are going to learn how to minimize that finite state machine. Minimization, which is nothing but reducing the number of states, or we can also say that reducing the number of transitions, that is a move from one state to another state, which is nothing but the minimization. So now let us see here. There are two states Q1 and Q2 which are equivalent if both the transitions Q1, x and also Q2, x are final states, or both of them are non-final states. That means the transition function, the answer of the transition function should belong to either to the final state or to the non-final state, but it should not belong one to the final state and another to the non-final state. So then we are going to minimize the finite state machine. So here we are going to divide the states given in the transition diagram as set of final states and set of non-final states. So here let us solve one problem in order to know how to divide the sets into final states and non-final states, and also how to take the transition functions of Q1, x and also Q2, x. So here we are given with a question: construct the minimum state automaton for the following transition diagram. Here for this transition diagram, if you observe, Q3 is the final state which we have, and also from Q0 to Q7 every state except Q3 is a non-final state. So here we are going to construct pi 0, pi 1, pi 2 and so on. So for pi 0, here we are going to consider a set of non-final states and also a set of final states. So here the first step is, step 1 goes to step 1, construct pi 0, right, which is the starting and the initial step. Construct pi 0, and here pi 0 is equals to, which is Q1 0 and also Q2 0. So that means what is Q1 0 and what is Q2 0? Here Q1 0 is nothing but set of non-final states, and here Q2 0 is nothing but it is a set of final states. That means we are going to divide the given transition diagram as set of non-final states and also the set of final states. So let us write pi 0 is equals to, we are having only Q3 as the final state, so the remaining every state is a non-final state. So here Q0, Q1, Q2, Q3 is a final state, so we are not going to write it here. We are going to write Q4, then Q5, Q6 and Q7. This is one set which consists of only non-final states, and Q3 is the final state. This is our pi 0. Now we are going to construct pi 1. So how do we construct pi 1? Here we are going to check the equivalence within the sets. That means we are going to compare Q0 with each and every set here, each and every element present in this set. Here there is only Q3, so we are not going to compare Q3 with Q3 itself, right? So here Q3 is the same thing, but here in the non-final set, Q0 is compared with each and every element present in the non-final set. So now let us compare Q0 and Q1. Then what happens is, here for pi 1, transition function of Q0, A, right, because input symbols are A and B. So here transition function of Q0, A is nothing but Q1, and we are going to check the transition function of Q1, A. Q1, A transition function is also nothing but Q0, because here Q1 and Q0 belongs to the same set, so there is no problem. Then transition function of Q0, B, because we are having another input symbol. Q0, B is equals to, here we have Q0, right? So here it is Q0, and transition function of q1 comma b is equals to q2. So if you carefully observe, q0 and q2 also belongs to the same set, which is non-final set. So we can say that q0 and q1 are one equivalent. Because why are we saying it as one equivalent? Because we are constructing pi 1. So it is one equivalent. Now compare q0 with q2, because we are done with q0 comparing with q1. So now we are going to compare q0 with q2. So for constructing pi 1, transition function of q0 comma a, which is q1, which we have already written, and the transition function of q2 comma a will become q3. And here transition function of q0 comma b is equals to q0, and transition function of q2 comma b is equals to q1. So if you observe here, under a column, that means if you apply a input symbol to q0 and q2, then here we are getting q1 and q3, where q1 lies in the non-final set and q3 lies in the final set. So that means two different sets it belongs to. So that means under column A of q0 and q2, let us write it here. Under column A of q0 and q2, we get q1 and q3, right? So they lie in different sets. So they are not one equivalent. Therefore, not one equivalent. Okay. Now we are done with q0 comparing with q2. Now we are going to compare q0 with q4. So compare q0 with q4. Compare q0 with q4. So here what happens is, transition function of q0 comma a is equals to q1, and transition function of q4 comma a will become q3. And here transition function of q0 comma b is equals to q0, and transition function of q4 comma b is equals to q5. So if you observe, q0 and q5 belongs to the same state, but q1 and q3 does not belongs to the same set. So we can say that under column A, q0 and q4 lie in different sets. So that means what? They are not one equivalent. Now we are done with q0 comparing with q4. Now we are going to compare q0 with q5. So compare q0 with q5. So transition function of q0 comma a is nothing but q1, and the transition function of q5 comma a will become q6. Transition function of q0 comma b is equals to q0, and transition function of q5 comma a is equals to q4. So here if you carefully observe, q1 and q6 belongs to the same set, and also q0 and q4 belongs to the same set. So therefore they are one equivalent. So now we have compared q0 with q5, and we should also compare q0 with q6 and q7. So let us compare q0 with q6, q0 and q6. So transition function of q0 comma a is equals to q1, and transition function of q6 comma a is equals to q5. Transition function of q0 comma b is equals to q0, and transition function of q6 comma b is equals to q6. So that means if you observe here, q1, q5, q0, q6 all belongs to the same set, that is non-final set. So therefore they are one equivalent. Now we are going to compare q0 with q7. Transition function of q0 comma a will become q1, and the transition function of q7 comma a will become q6. And transition function of q0 comma b will become q0, and transition function of q7 comma b will become q3. So that means if you observe, Q1 and Q6 belongs to the same set, but Q0 and Q3 does not belong to the same set. So under column B, Q0 and Q7 lie in different sets. So therefore you can say that they are not one equivalent. So in this way we are going to compare each and every state with Q0. So now we should get pi 1. What is the set of pi 1? How do we know what is the set of pi 1? Here Q3 is a set which is already confirmed and we are not going to change that set because we have nothing to compare with Q3. So here under Q0 and Q1 it was one equivalent. For all one equivalent it belongs to the same set, but under column A, for each and every sets which are lying in different sets under column A will be one set, and all the sets under column B will be belongs to another set. So that means we are going to write pi 1 is equals to one set is Q3 and the another set is Q7. Because Q7 only belong under column B, only Q7 belongs to different set, so it is not one equivalent, so it is Q7, and also Q2 comma Q4, because Q2 comma Q4 are not one equivalent under column A, so only Q2 and Q4 belongs to one set, and again Q0, Q1, Q5 and Q6, Q0, Q1, Q5 and Q6 belongs to another set. So in this way from pi 0 to pi 1 we are going to divide into different sets so that we are just minimizing the given transition diagram, that is the finite state machine. So here Q3 is completely its own set. Q7 is also its own set. We can't compare it with another elements because there is only one single element Q7. So now we have to compare Q2 with Q4. If it is not one equivalent, then we are going to change the set, or if it is one equivalent, then the set becomes as it is. Now let us compare Q2 with Q4. Compare Q2 with Q4. So transition function of Q2 comma A and transition function of Q4 comma A, and transition function of Q2 comma B and transition function of Q4 comma B. So what is the value of transition function of Q2 comma A, which is nothing but Q3, and Q4 comma A is equals to Q3. So both Q3 belongs to the same set, so it is one equivalent. Now let us see under column B. Q2 comma B is equals to Q1 and Q4 comma B is equals to Q5. So both belongs to the Q1 and Q5 belongs to the same set, so therefore they are one equivalent. So we are not going to change the set of these three because they are one equivalent. Now we are going to compare Q0 with Q1. Compare Q0 with Q1. So transition function of Q0 comma A is equals to Q1 and transition function of Q1 comma A belongs to Q0. Now transition function of Q0 comma B belongs to Q0 and transition function of Q1 comma B will belongs to Q2. If you see here, Q1 and Q0 belongs to the same set, so no problem. But Q0 and Q2 is in another set, Q0 is in another set, so therefore under column B they are not two equivalent. So this is not one equivalent, right? Here we are going to construct pi 2, that means it is two equivalent. Under column B it is not two equivalent. So that means we have to again compare Q0 with Q5 and Q0 with Q6 as well. So now let us compare Q0 with Q5. Compare Q0 with Q5. So transition function of Q0 comma A and the transition function of Q5 comma A. We should also find transition function of Q0 comma B and transition function of Q5 comma B. So here, if you see, transition function of Q0 comma A is Q1 and transition function of Q5 comma A is equals to Q6, and Q0 comma B is equals to Q0 and Q5 comma B is equals to Q4. So if you carefully observe, 1 and 6 belongs to the same set, so it is 2 equivalent, and Q0 and Q4 belongs to another set, Q0 belongs to another set. So under column B it is not 2 equivalent, right? So under column B it is not 2 equivalent. So now we are going to compare Q0 with Q6. So compare Q0 with Q6. So that means transition function of Q0 comma A will become Q1 and transition function of Q6 comma A will become Q5. And transition function of Q0 comma B will become Q0 and transition function of Q6 comma B will become Q6. So in this way we are going to take the values. Now let us see whether they are belonging to the same set or they are belonging to another set. So here Q1 and Q5 belongs to the same set, so there is no problem, and Q0 and Q6 also belongs to the same set, so therefore they are 2 equivalent. So if you see, Q0, Q6 and Q2, Q4 are 2 equivalent, but the Q0, Q1 and Q0, Q5 are not 2 equivalent. So let us write pi 2 is equals to Q3 is as it is first 3 sets were as it is in pi 1, right? So first 3 sets are as it is, Q3, Q7, Q2 and Q4 are as it is. So but from Q0, Q1 they are not 2 equivalent under column B, and also Q0, Q5 are not equivalent under column B. That means what? Q0 here, Q0, Q1 and also Q0, Q5 are not 2 equivalent, right? So here we are going to take it as Q1, Q5 and the remaining Q0 and Q6 as one set, because they are not belongs to Q0 and Q6 are 2 equivalent, but the remaining 5 and 1 are not 2 equivalent under column B. So Q3, Q7, Q2, Q4 are same as it is from pi 1, but Q1 and Q5 are not 2 equivalent under column B, so we are taking as another set, and Q0 and Q6 are 2 equivalent, so we are going with the same set. Now we are going to construct pi 3. Till now we have constructed pi 0, pi 1 and pi 2. So now we are going to take pi 3 because we need to continue this process till we get all the equivalents. So in constructing pi 3, see here Q3, Q7 are not going to be compared with anything because in their own set there is only one state, which is Q3 as well as Q7. Now compare Q2 and Q4. Compare Q2 and Q4. So transition function of Q2 comma A will become Q3 and transition function of Q4 comma A will also become Q3, and transition function of Q2 comma B is equals to Q1 and transition function of Q4 comma B is equals to Q5. So here Q3 and Q3 belongs to the same set, so there is no problem. Q1 and Q5 belongs to the same set, so therefore they are 3 equivalent. Now we are going to compare. We are done with Q2 and Q4 also. Now we are going to compare Q1 and Q5. So transition function of Q1 comma A which is q1 comma a value is nothing but it is equals to, here we are going to check the transition function of q1 comma a, which is nothing but q naught. So transition function of q1 comma a is equals to q naught, and transition function of q5 comma a is equals to q6, and transition function of q1 comma b is equals to q2, and transition function of q5 comma b is equals to q4. So that means here q0 and q6 belongs to the same set, and q2 and q4 also belongs to the same set, so therefore they are 3 equivalent. Now we are done with q1 and q5 also. Now we are going to compare q0 with q6. So here let us write compare q0 with q6. Transition function of q0 comma a is equals to q1, and transition function of q6 comma a is equals to q5, and transition function of q0 comma b is equals to q0, and transition function of q6 comma b is equals to q6. So here if you observe, q1 and q5 belongs to the same set, and q0 and q6 also belongs to the same set, so therefore they are 3 equivalent. So now here we will wind up here, because we are compared each and everything till we got all the states as equivalent. So here constructing pi 3, which is equals to q3, q7, q2 and q4, q0 and q6, and q1 and q5. This is nothing but pi 3. So therefore the minimized finite state machine consists of 5 states. So this minimized finite state machine consists of 5 states, where q3 is one state, q7, 2 and 4, 0 and 6, 1 and 5. These are the 5 states which you will have in a minimized finite state machine. So now let us draw a transition table for minimized finite state machine by applying both the input symbols A and B. So here we are having these states as these are the 5 states which we have in a minimized finite state machine. Here our initial state is q0, so it becomes q0 comma q6 is the initial state. Then we are having q1 and q5, q2 and q4, q3, which was the final state actually, so we'll make it as final state here also, and also we are having q7. So now if you apply, how do you get the moves when you apply input symbols A and B? So if we are already having the transition table, so from transition table if you apply A to q0, then it becomes q1, and if you apply A to q6, it becomes q5. So this is our move. That means we are moving to q1 comma q5. Now in the same way you need to fill the table by applying for B, and also you are going to apply A and B to each and every state present in the minimized finite state machine. So now let us write it here, which is q0 comma q6, and here also we are going to q0 comma q6, and if you apply B, we are going to q2 comma q4. Here by applying A, we are going to the final state q3, and here we are going to q1 and q5, and here for q3 if you apply A, it goes to q3, and if you apply B, it goes to q0 comma q6, and for q7 if you apply A, it goes to q0 comma q6, and if you apply B, it goes to q3. So these are the moves which you get by considering the given transition table. So here now let us draw the transition diagram, that is minimized finite state machine. We are going to draw the minimized finite state machine. So our initial state is q0 comma Q0 comma Q6, right? This is our initial state. Q0 comma Q6 is the initial state. If you apply A, it goes to Q1 comma Q5. Q1 comma Q5, which is another state. By applying A, it moves to one state to another state, and if you apply B, it moves to the same state. So this is our first transition of initial state. Then if you apply A to Q1 comma Q5, it goes to Q0 comma Q6. That is, it come back if you apply A. Then if you apply B, it moves to Q2 comma Q4. Let us write it in this way: Q2 comma Q4. If you apply B, it goes to Q2 comma Q4. So for Q2 comma Q4, if you apply A, it goes to Q3, which is the final state. So what if you apply B, it moves to Q1 comma Q5. So again it moves back. Now if you apply A to Q3, then it goes to Q3 itself. And if you apply B to Q3, then it moves to Q0 comma Q6. Now the next one is Q7. So for Q7, if you apply A, it moves to Q0 comma Q6. That is, for Q7, if you apply A, it moves to Q0 comma Q6, and if you apply B, it moves to Q3. So like this. That means what? This is the finite state machine where we got only 5 states, but previously we were having 8 states from Q0 to Q7. So we have minimized the finite state machine from 8 states to only 5 states. That means 3 states were removed. So we have minimized it. So in this way we are going to minimize the finite state machine by considering pi 0, pi 1 and pi 2 and so on till you get all the states as 1 equivalent or 2 equivalent or 3 equivalent respectively. So in this way we are going to solve this kind of problems, and these are the most important problems for our external exams which can be expected for the 10 marks questions. So thank you for watching the video.